Okay, thank you for entertaining me there. We are going to talk about an ellipse today. And just like parabolas, an ellipse has a geometric definition, and our ellipse could be vertical or horizontal. So here's the geometric definition of an ellipse. The set of all points in a plane, the sum of whose distances from two distinct points is constant. Go ahead and just write it down and then we'll process it together. Foci is the plural for more than one focus. What? That you are condescending in root. Maybe you should really reflect. That was very nice. Okay, so an ellipse looks like an oval. Okay. And what's happening, there's not one focus, but there are two foci. And if we take any point on our ellipse, if we measure this distance plus this distance, it would be the same as if I took this point and I measured this distance plus this distance. And it would be the same if I took this point and I measured this distance plus this distance, and et cetera, et cetera, et cetera. I could keep being annoying, okay? Let me show you a little demonstration of that here. Okay, so as I move my coordinate M around, notice how we're measuring distances right here. So I need your help. Calculator or not, I don't care. What is 11.28 plus 3.88? What? Yeah. How about 7.21 plus 7.95? 1/6. How about 4.4 plus 10.76? Okay, so no matter where I move this point M, oh, I don't know why we're moving up and down here. No matter where I move this point M, those two segments are going to add to be the same number. Now I can, create a different size here. All right. And it would change, okay, the way that it looks, all right. But no matter what, wherever I move that point M, those two distances are going to add to be the same, okay? And that's the geometric definition of an ellipse, okay? Now, we are going to have what we call a major axis and a minor axis. Notice how one side of the ellipse is longer than the other, okay? So our major axis is going to pass through the foci, and it's going to be the longer one. The minor axis is perpendicular to the major axis, passes through the center, and it's going to be the shorter, okay? The major axis is going to be longer. The minor axis is going to be shorter. It is going to be symmetric. Is that your question?
Yeah.
Okay. Okay, so once again, I have a little card for you to glue in. Forgot to get the glue out, sorry. I have a card for you to glue into your notes. Hey, light bulb incoming. All right, so we can glue in this pink card. Okay, glue this in and then we're gonna make some notes about it. Okay, so a couple things I want you to notice. We have x squared and y squared now, okay? We still have this x minus h and y minus k. However, when we're working with an ellipse, and then tomorrow with our hyperbola, our center is what we identify as HK, okay? Our center is what we identify as HK, okay? Now, I want you to look, there's a squared and b squared. What do you notice about our horizontal versus vertical equation? The denominator switch, okay? This is because A is always greater than B, and A is associated with the major axis, okay? So if the bigger number is underneath the x squared, we have a horizontal ellipse. If the bigger number is under the y squared, then we have a vertical ellipse, okay? A is going to tell us where our vertices are, okay? So we identify a squared, take the square root to get a. From the center, we are going to move a away to get two vertices. So if we have a horizontal ellipse, we'll move a horizontally right and left. If we have a vertical ellipse, we'll move a up and down. Okay. B then helps you identify your minor axis. Okay. So we're going to use B to go the other direction, and we'll plot these points. They're not called vertices, but they're important for our shape. Okay. Once we have our vertices plotted, the end of our minor axis plotted, then we can get our shape. Okay. Now, notice how our foci, you know, those important points that we talked about earlier, our foci get plotted along the major axis. So whichever direction you went for your vertices, that's the direction you're going to go to plot your foci. Now, it says that foci, we use this number C for that distance, okay? Notice here, C squared equals A squared minus B squared. A squared is C squared minus B squared. Okay. That is how we determine C. Okay. C is often going to be an irrational number. That's okay. All right. Okay. So here's just some notes. All right. This is what I talked about. You don't necessarily need to write these down unless you think you need to. Okay. Our vertices, we use A to figure out how far they are away. Our minor vertices, our minor endpoints are B away, and then the foci are C away. All right. So if you need to make those notes just to interpret what that pink picture is telling you, that's fine. If you don't need them, also fine. Yep. Okay, so do we all agree that these ellipses look like? Okay. So we have a measurement for how oval, well, pretty soon, we're gonna have measurement for how oval our ellipse is. Okay. Are you making obnoxious comments? So yes, you're making obnoxious comments. Okay, how long is the major axis? From end to end, how long is it? Not A squared. A plus A. We go A from the center to the right or left together. That's 2A. How long would the minor axis be? 2B. Or not 2B. Trying to lighten the mood, but what's true about our ellipse if A equals B? Which means we have a circle. Now, we have one measure that we need to calculate after we get everything graphed. Eccentricity is given by C divided by A. Eccentricity, C divided by A. It measures how oval our ellipse is. Is it more circular or is it more squished? That's what eccentricity measures. eccentricity is always going to be between 0 and 1. Closer it is to 0, the more circular we are. Closer it is to 1, the more squished we are. I'm sorry that you feel that way. Don't you feel like most things in here feel made up? Okay. We're going to graph 2 ellipses if that's okay with you. Are you ready to graph 2 ellipses? Awesome. First one. Write it down, and at your pod, I'd like you to decide whether this is going to be a vertical or a horizontal ellipse. Where? Right here. Not sure if you keep up with me. Right, like right now? Well, what if it puts words up there? Oh. Yeah. Well, sorry. You watch TV with closed captions? Random question. How many of you watch TV with closed captions on? Okay. We totally, I didn't growing up, but I do now, and it like everything just makes sense. Okay. Especially when like you're watching something and they have accents, it's no, I can hear it, but sometimes like you think it's distracting? I think it helps like me process like what they're actually saying. Mhm. Okay, so Richa, what did your table decide about this being horizontal or vertical? Okay, so a squared or a is our bigger number. 4 is bigger than 1, and 4 is attached to the x squared. So this is horizontal. Okay. Finn, where would our vertex be? Oh, well that would be, okay. So this is x minus h and y minus k. So we're gonna call our vertex -3, 1. And Mrs. Homan, yikes, yikes, yikes. That's not the vertex. No wonder you were confused. That's the center. That is the center. I'm so sorry, Finn. I did not set you up for success there. -3, 1 is our center. Okay, now we've decided that 4 is a squared and 1 is b squared. So let's go ahead and make a note over here that a is 2 and b is 1. How did I get that? If a squared is 4, I took the square root to get 2. If b squared is 1, I took the square root to get 1. That's kind of boring though. Okay, all right. So since this is horizontal, I'm gonna come over here to my center and I'm going to move horizontally A. So I'm gonna move to the right A, and I'm gonna move to the left A. And there are my two vertices, and we need to label them. So vertices. -5, 1, and -1, 1. Everything is from the center. Okay, all of our distances are from the center. All right, now B we identified to be 1. B is associated with y squared, which means we're going to move vertically. Y is the vertical variable. We're going to move vertical 1. Beautiful ellipse. Okay, now we need to plot our foci because really our foci are pretty important. Okay, so we decided that c squared is a squared minus b squared. Well, a squared is 4 and b squared is 1. I got those just from looking right here, our denominators. Okay, so c squared is, so c is radical 3. Well, how do I plot a coordinate radical 3 away from the center? We can approximate, right? Radical 3 is bigger than, but not quite 2. Radical 4 equals 2. So radical 3 is almost 2. Okay. So from the center, and we have a horizontal ellipse, I'm going to go horizontally, so to the right radical 3 and to the left radical 3. What? What just happened over there? Now, we also have to name them. We took our center and we went to the right radical 3. So we took our center of -1. What was our center? -3. -3, 1. And we went to the right radical 3. We took our center of -3, 1. And we went to the left radical 3. So since we went right and left, we added radical 3 and subtracted radical 3 to our x coordinate. Are you okay with how I wrote that and why I did the x coordinate? We moved right and left, so we added radical 3 to our x, subtracted radical 3 to our x. And there's our ellipse. I think ellipses are one of the easier of the 3 to graph. Okay. Do you have a question? Nope. Vertices, foci, ooh, and eccentricity. Eccentricity is C over A. We're done. That's it. Now, if this were not simplified, we would have to simplify it, but we're good. All right. Should we do another one? Sure. Thanks, Nick. Nick's excited. What do you think my next example is going to be? Potentially vertical. What else am I going to do here? It's not in standard form. But that's actually, I feel like makes more sense when we do the algebra. Okay, so write this down. We're going to do the same thing, but we need to do some algebra in order to be able to get this into standard form. Okay. So first of all, let's talk about how we know this is an ellipse. X squared and y squared are there. So we know that that's true. Something else that we're going to have to look at. Both of them are positive. If both of them were negative, it'd be the same kind of deal, but they both have the same sign. So specifically, it's going to be an ellipse. Tomorrow, we're going to look at hyperbolas. They're going to have opposite signs for x squared and y squared. Okay. If this was a circle, x squared and y squared would have the same coefficient. Okay. All right. So how many times are we going to have to complete the square? Twice. We are going to factor out the 9 out of our x squared plus 36x. We are going to factor the 4 out of our y squared minus 8y. Because we cannot complete the square if our leading coefficient is not 1. Ooh, have I written that other 4 yet? No. What I'm going to do is I'm going to take that constant. I'm going to take that constant. I'm going to move it over to the other side. So I'm going to subtract 4. And then I'm going to add my 2 mystery numbers. Okay. I add 2 numbers over here. So I'm going to add the same 2 over here. Okay. Hank, what completes my square in this first? B over 2 squared would give us 4. But are we adding 4? We're adding 4 times 9. We're adding 36. Yes. Yep. B over 2 squared. Okay. Okay. So here, Eric, complete the square. B over 2 squared would give us? Yes. But we're not adding 1. We're adding 1 times 4. So we have 9 times the quantity x plus 2 squared plus 4 times quantity y minus 1 squared equals 36. Where are you lost from? The blue ones? This? Yeah. So this factors to x plus 2 times x plus 2. So I write x plus 2 squared. This factors to y minus 1 times y minus 1. Okay, now standard form. What do we need on the right side of our equation? Not 0. 1. So we're going to divide by 36. Because 36 is what we have on the right. And we want fractions, right? So we get x plus 2 squared over 9 divided by 36 is going to leave us with 1 over 4. Plus y plus 1 squared over 9 equals 1. Here's our standard form equation. Hey, were you right? Yes. It should be. I made a mistake. I'm sorry. Okay, now were you right? Is this a vertical one? Is this a vertical one? You betcha. Our bigger denominator is 9, and 9 is under the y squared. So we have a vertical ellipse. Luke, where's our center? -2, 1. Grab the x and the y. -2, 1 is our center. I really like that coordinate, apparently. That's popping up in a lot of our examples. Okay, so you told me, well, we talked about how 9 is bigger. So 9 is a squared and 4 is our b squared. Okay, which means a is what? A is 3. And since a is with the y, our vertical variable, we're going to go up 3 and down 3 to get our vertices. So -2, 4 and -2, -2. We're then going to use b. We decided b is going to be 2, since b squared is 4. I'm going to move to the right 2 and to the left 2 so I can get the shape of my ellipse. Probably the more challenging part of this is trying to get your ellipse to actually look round, right? I kind of get a cheat because my iPad makes it nice and round for me. Okay. All right, now we also need our foci. C squared is a squared minus b squared, which would give us square root of 5. If I were to measure out the square root of 5, what's the perfect square that 5 is the closest to? 4, the square root of 4, which is 2. 5, so square root of 5 is just going to be a little bit more than 2. Are we going to move vertically or horizontally? Vertically, because we have a vertical ellipse. So a little bit more than 2 up, a little bit more than 2 down. And I know that it's a pain in the butt to write these coordinates when you have an irrational C value. So I'm going to give you a little bit of a break here. You can say that our center is -2, 1, and we moved up and down radical 5 from our y coordinate. So you can write this as just like one coordinate with a plus or minus. 1 plus radical 5 was one of our y coordinates. 1 minus radical 5 was another one of our y coordinates. Now look at me. Don't you ever do this with an integer. If you give me -2, 1 plus or minus 2. No, you can actually tell me what those two coordinates are. Okay. If it's irrational, you can do this. Okay. Hey, we've graphed 2 different conic sections now. Okay. Heck yeah. Make sure you practice those ellipses tonight, Owen.